Everyone, welcome to Getting Started with Golang Hands-On. And today we are going to learn about slices in the Golang. And one thing to start with, we'll try to follow go by example. So it has some nice examples to start with. I'm not going to cover all the basic stuff, so I would recommend to uh, read it from here or somewhere wherever you find it relevant. So today let's learn about the slices, and here again I will not dig deep much into the theoretical aspects. Um, my idea would be to understand from the practical point of view how it is being used and the relevant operations. And so let's get started. And so this is the dev environment. I have separate videos for how to set up the Golang dev environment and also how to set up the virtual box for the development purpose. I'll paste the link in the comments. So let's get started. So at a very high level, slice is similar to an array, but it's dynamic. For the array, you need to before and specify the size of it, and slice is dynamic in nature. Every time when you're adding elements, you don't need to explicitly take care, okay, how much memory you have already allocated and whether that would be sufficient for the new elements which you are adding. And with that respect, the initial declaration here, for example, this ARR is in a slice variable, and this is the notation how you uh, define a new slice, and you are here specifying that you are planning to store int elements, and this is again like array of int in the Golang. And initially you are you're just allocating the space for two elements, but yeah, if you even if you're adding more than two elements and all, it will automatically take care of that. It's just to make sure that okay, these many elements you want to allocate it beforehand. This see, one or two, these small number doesn't make much difference, but in the actual uh, dev environments where when you know these 1,000 elements I want to be pre-allocated rather than every time the go runtime it's allocating using the exponential backoff or whatever algorithm it's using for every time reallocating whenever the size is not sufficient. Initially, if you want to specify these many elements I want to pre-allocate it, so that you can specify here. And so this is the code in the GitHub account. I'll also paste a link for it so you can download it and work it through. So the same program I'm running here. Again, the Go program, either you can run using the go run command, or you can generate the binary. So this is, or you can generate the binary using the go build command. So then it will generate the binary and you can run that binary as well. Anything is fine. So let's dig deep. Let's at very high level, right? If you, even if you think about slice, what are all operation you want to perform, and basically it's like addition, deletion, appending those two slices. And there is also very interesting slicing operation which is also there in the Python, and actually frankly I learned it from the Python. And so basically there is I'll put the link for that as well. There is this Google Python classes. This is a 2 days workshop, and that's very good to start with the Python. I'll put the link for that as well. From there I basically got the idea of slicing, and the same concept is being used here. And frankly, Golang picks good stuff from many languages, and so yeah, at least the slicing part I felt it pretty similar to the Python thing. So let's get started. So this is the initial. We are defining a slice of size 2, and we are planning to store int elements in it. And so you can define it with other data structures as well, but to keep it simple, and as we are just getting started for this class, let's keep it as int only, and I'll show all the int related operations, but those can be performed for other types as well, and also for the user defined type, other objects as well. So I think we'll go into those details later, but let's stick to the int thing. So okay, it's similar to an array, and it's similar, update a value at any index. So here I'm updating a 0. So initially when you initialize and you specify size, and you don't uh, basically you don't initialize with any elements, you're just specifying the size. It needs to be 2. So by default it will be initialized with a 0 value. For int, the 0 value is 0. For example, for boolean the 0 value is false, and for the float it will be 0 dot 0, and similarly for others. Yeah, for int it's 0. So when we are initially initializing and I'm printing this array, you see it contains only the 200 elements. And next, what we are doing, the 0th index I'm assigning 1 slice after updating value at 0th index, and you see it got updated. Then we see read value at any index. This is also straightforward. Whatever is the 0th index, I'm reading it, and it's the value 1 which I just wrote, so that's also fine. Next, we'll see append operation. Again, this is similar to we use in the Python, only the syntax might be a little different, but once you keep practicing, yeah, you will be familiar with the syntax. And here what I'm trying to do, so this slice, I want to append one more element, 3, and after appending 3, what it becomes, yeah, 3 is appended here. Earlier only 10 was there, now we see the 3. And the len is very handy function for basically getting what the current, how many elements are there currently. So it just prints 3 because we have 3 elements currently. Creating a new slice and copying, so that also sometimes in practical scenarios we might need it. I'm basically creating a new slice here, and what's length I have given for the initialization, the length of the older slice, and I'm just copying using the copy operation. So this is completely new slice, and yeah, and we are explicitly copying it here. Okay, and I think, yeah, and then we are printing the array 1. So yeah, the new slice we are printing, and that okay, that seems fine. Now what we are doing, we are appending slice to slice, and the older and the newer, and the result is stored here, and I'm printing the result, and we'll see after appending we see the new slices like this. So there is another way of initializing the slice where we want to specify the initial element. This is called the slice literal. So similarly for other data structures as well, we can initialize them by providing some initial values, and this is one way of initializing the slice. If I print it out, it will just print these elements. If we see here, okay, now iterating through the slice, that's also a common requirement. You want to iterate through a slice, and so we have this range function again. So this range, if you see this range function, yeah, here, if you click it, yeah, it'll explain the further details. So I'm directly using it. You can get more details here. Again, go by example for getting the initial relevant stuff. So basically it range specifies, okay, you want to range through the all the elements of the slice, and it returns 2 values in each iteration. One is the index and one is the corresponding value, and what I'm doing, just printing it, and the index is common to any other language. It's 0 to n minus 1. Suppose you have n elements in the slice, the index will vary from 0 to n minus 1. So we have 5 elements, index is varying from 0 to 4, and the actual elements are themselves 0 to 4. So if you see the 5 elements we have, yeah. Now this is what I was mentioning, slicing the slice. I just copied this code. I think it's in the same the Google Python classes that you Google it, you will get it. I think, yeah, in that the lecturer mentioned it, slicing the slice in a funny way. So those are just awesome classes. And slicing means basically when you want to access a sub part of a slice, and this is the syntax, and this is the Stack Overflow link which I found useful. So this is also there in the code, you can refer it. And this is the syntax. You basically specify a start and a stop index, and based on that, it will return the subpart of the slice. So one thing is to remember whenever you are specifying the start and stop, so you will see the elements starting from the start index, but the stop index is not considered. It's only considered till stop -1. So we'll see the examples for more details, but just to remember, whatever the first index you are specifying, that will be considered at it will start from there itself. But the second index which we are specifying, um, it will go through one minus, basically stop -1, through stop -1, and stop index it will not be considered. um, I think it will be more clear when we'll be using some examples. And if you're not specifying the second argument to it, it'll consider everything. Items start through the rest of the array. It'll start from here and all the elements after it. If you're not specifying the first parameter, then it'll start from the beginning. If you're not specifying the second, it'll go till the end. And as we know, the second argument, whatever we are specifying, it'll be go through stop -1. So that, and if you're not specifying both, the complete slice will be considered a copy of the whole slice, or a slice is more appropriate rather than array. So let's go through the example. So when we are trying to print the complete slice, right, I didn't specify any starting start or stop parameter for the slicing. So it will print everything 0 1 2 3 4. And you should also work out with these examples, only then you will clear. If you already have an idea from the Python background or something, so then it's clear. But if you're new to it, you might be needing some practice, only then it will be clear. But this is very interesting concept. I recommend to work it out, and it's very useful actually, also for the competitive programming. Okay, the next thing, suppose I want to get the last element. So normally how we get the last element, if suppose you have n elements and index varies from 0 to n-1, so you only need to get the index n-1. But how will you get the value of n, how many elements you are? So this len function will come for alpha. So we have these n elements and n-1, the last index, so we are just printing the last value. And if you see last value is 4, we are printing that. Now some other examples of the slicing. I only specified the start parameter, and the second parameter I am not specifying. So it will start from the second index and it will go till the end. And what is the second index here? 0 1 2. So it will print the 2 3 4. Yeah, it's printing the 2 3 4. So that is interesting. Here we are not specifying the first index, so it will start from the beginning, and it will print values till the index 2 -1. So how many values we have? 0 and 1. So at 0 and 1 we have 0 and 1, so only 0 and 1 will be printed. Only 0 and 1 will be printed. Similarly, here we are specifying both. It will start from the first index, but it will go till 4 -1, which is 3. So 1 2 3. So, and one index and the third index, and so we'll see the element 1 2 3. That is it. Simple, right? Yeah, you'll work out a bit. It'll be very complete slice. You can just print, it'll print everything, so you can print directly. And remove an element. So removing an element also important operation, and here we are seeing two ways of doing it. Again, the Stack Overflow link is there, so you can further go through it for more details. So removing an element, okay, it depends on the requirement, whether we want to maintain the order or ordered is not needed. So if we want to maintain the order, in the worst case it will go order of n, and if we do not, we don't care about the order, it can be done in order of n. Okay, let's see the implementation. So if you see in the ordered, remove ordered, right, what it's trying to do. So this is an array, and we want to remove an element at the ith index. So what it's doing, first it's slicing from the beginning to the I minus 1 index, because remember the second parameter, if we are specifying I, only elements till I minus 1 will be considered. Okay, so the ith element is not here, and so basically he's appending the two lists. This is one. The second, he's starting from the I plus 1. So again here he's not considering I and all the elements after that. So here we are considering all the elements before the ith index and all the elements after the ith index and appending it. And appending the slices, so this is specific Golang syntax. You might want to take a look, but basically what you are doing, so here all the elements before the ith index, all the elements after the ith index, we are appending it and returning it. So it will basically removing the ith element, and it's ordered, means the ordering of the elements has not been changed, and this can be order of n. So why it's order of n? Because this append operation. So if there is, suppose only one element is there and there are n minus 1 elements, and so appending all the element, basically it might take order of n roughly. And because one or two element that's just constant, so when you go to the big O notation, it ends up in the order of n. Now if you don't care about the order, so what here doing, we'll just see. So what this guy is doing, some basic sanity check is done, that's good. But basic operation I will just try to explain what it's trying to do. Len of a, how many elements are there, minus 1 means he's getting the last element and it's copying into the ith index, because we don't need the ith index value anymore. And what it's returning, len a minus 1. And if you remember in the slicing, so this is the slicing syntax, and if you are specifying this, so the last elements will not be considered, and that element is already being copied here, so we don't care if we ignore the last element. So that is being removed, and it's returned. Okay, so that was it for now, and I'm not sure if it was too fast, but I would recommend practicing, and if any doubts, please drop a comment, and I'll try to clarify that. uh, th Thank you guys for and all the relevant links I'll post in the description section. Okay, thank you for now.